So continuing from our last video, let's just do a little review here first. So we took our section, in this case 1.3, and we highlighted all of our learning goals, right? S for strategic. The A actually wasn't a learning goal, right? It indicated that I could possibly use this as an anticipatory set. Right? D for declarative. You can see I have P's for procedural, and I have C's for conceptual. Remember, on our conceptual now, we indicated that we made it an activity, right? Because conceptual now, we're shooting for understanding. We're trying to make a connection between the declarative and the procedural, right? So we may need something a little bit more substantial than just a lecture. If we go through our entire thing, you can see all my activities, all my conceptuals, my declaratives, all that good stuff. All right, so we left off in our lesson plan. We came to the linear model, so this was our definition. So if we look at our lesson plan, we did our linear model. And I left some arrows, some spaces, because I want the kids to come in and fill those in with their own words. Right? And now we're up to the part where I'm up to these conceptual. So I have initial value. I have that as my conceptual goal. And I'm going to need an activity. Right? And I have B, the constant amount by which Y changes, right, for a unit increase in X. So I don't think that's straightforward. I think students will need to unpack that with an activity to get students to really understand what that means. All right, now having said that, when I say activity, I want to be clear though, an activity could be, let's do this, activity. It could be anywhere. It could range from simple questioning, so a class question, a little group question, all the way to some large scale activity where, it's well organized, we have manipulatives, we have all that good stuff. So it's a whole continuum of things I can do. So when I say activity, I don't necessarily mean a whole curricular development. I mean just something that engages the students to go beyond just knowledge, right? To go beyond just direct lecture. So it could be anything from questioning, right? And then this could go all the way to the other side of the continuum, right? To any kind of big scale activity. All right, so large scale. And, manipulatives, anything like that. Right? But well organized, that kind of deal. Not that your questioning is not well organized, but see, the point is from kind of a low end to a very high end structured activity. And somewhere in the middle here, well, it doesn't have to be the middle, right? But somewhere in your continuum here, right, we're going to actually have where students do individual work. Okay, so when they work individually, it's somewhere between, I don't necessarily question them, I don't necessarily have a huge activity planned, but somewhere in here they do individual work. And now when we talk about individual work, there's kind of two things we can talk about, where they practice. So there's nothing wrong with practicing for declarative knowledge or procedural. So maybe doing flashcards, but reviewing repetitively for declarative knowledge, or just practicing procedure over and over and over again. There's nothing wrong with that. But also we could do individual work where we're trying to construct understanding. Okay, so we're trying to construct understanding. Our individual work won't be just rote practice and worksheets. We're going to have to come up with something a little bit more dynamic, right? A little bit more engaging. All right, having said that, let's go back to our section. And so now what I want to do is I need an activity that's going to get at what initial value is. Before I can decide what activity I want, whether I find one or make one myself, we have to really unpack what we think initial value is. So if we go back to our learning goals, right, so I go to the top here, you can see initial value is just this. My learning goal is y is the initial value when x is 0. I want kids to understand why initial means x is 0. And I've unpacked it to mean this. Right? So this is my understanding of what initial is. And I've done all this myself. And this is the important part of really unpacking your learning goals, really getting comprehensive learning goals, so that you can think about it in a way that will help you develop activities. So now I think that initial just means, start. Right? So it means beginning, and beginning's when x is 0. Okay, now this is important because I think that everybody has an idea of what initial means. So now I have a set of students where I want to get them to understand that initial means start, it means beginning, it means x equals 0. And I think they already have that knowledge they already understand that. And I think they already have that as prior knowledge. Right? So that's why when you look at my activity here, my activity is simply going to be, I'm just going to do a class question. All right, I'm going to ask the class. When I say this, I like groups of 4, so I'd have them in groups. I'm going to ask the class, in their groups of 4, what does initial value mean? What does it mean to really be initial? And then we can have quick little discussions. And you see I allotted 45 seconds of partner discussion time, and then we'd come back as a class. Right, now keep in mind, this is the low end of the activity spectrum, and I'm doing this, or I'm able to do this, because I think they have this prior knowledge already. If they didn't have some sort of idea of what initial meant, I couldn't do just a simple questioning technique. Okay? All right, let's go back. So now I have my activity for initial value. Now I want to develop an activity for B, meaning that it's a constant change in Y for a unit increase in X. So to do that, I don't think they have prior knowledge here. I don't think students really have a prior knowledge of what a constant change of Y with a unit increase in X. So I can't just do this with a class question. If we go back to my lesson plan, how did I unpack this? So here's my goal, my learning goal. Was what does it mean for B to be a constant amount by which Y changes for each unit increase in X? And to me, this means that the model actually forms a line. Right? Now we're talking about slope. Now, slope doesn't have to have that unit increase in X, but I think we can get at the idea if we really kind of investigate how lines have slopes and how curvilinear functions don't have slopes, right? Not constant slopes, at least, right? So, having unpacked that, I'm going to get at this through actual lines. So now you'll see my second activity, I actually have these graphs, okay? And so now what I want to get at is that if we actually follow these graphs, and I'll read the instructions a little bit here, but if we follow these graphs, you'll notice that every time I have a constant unit increase in X, I have the same increase in Y no matter where I start on the line. Doesn't matter if the slope is positive or negative, no matter where I start, I'll still have that unit increase. I'll have that constant change in Y for whatever change in X I have, right? As long as I keep it constant. Right? And then you'll see I have C here. That's this is actually an exponential function. That'll show them that that's not the case when it's a nonlinear function. Okay, and so you'll see here for graph A, I'll tell them, and this is something I would pass out, right? So I'm going to give each group a copy of these three graphs. When I say group, I'd probably give each individual a copy. I'd still have them work in partners, right? Teams of two, but each one would have a copy of these graphs, right? Or I might just give one to each set of two teams, right? So each team with the two people. All right, so then I'll start off and I'll say, hey, start anywhere on the graph. So on graph A, you put your pencil or pen anywhere you want, and then go right one, and then how many do you have to go up to hit the graph? And then I'm going to have them repeat this for different starting points. And then we'll notice when they do that, we'll come together. I'll have probably a follow-up class question maybe, and then we're going to really unpack that every single time, no matter where they start. If they go a unit increase, and I can talk about increases in X, right? Going to the right. Right? We start at 0, and as we increase, we always go to the right. Okay, so those are little things I can add in as we're doing this activity. Well, when we do this, we're going to get this constant rate of change, right? And that's the slope idea. Okay, and then I'm going to unpack the idea of this unit increase. So instead of going 1, we're going to go right 5. And then we're still going to be able to unpack this idea that I have this constant slope here. All right, so I'm doing two things with this activity. One is I'm getting at this constant amount of change in Y, right? And the other is I'm actually trying to get them to realize a unit increase doesn't have to be the case, right? I can have more than a constant increase by 1, right, in X's. I still get the same slope. I still get the same rate of change, right? But the key here is it's going to be linear, right? So I'll do all that. Then I'll repeat for graphs B and C. Right? And so we're going to unpack the idea, right? So we're unpacking two ideas here. That we get a constant slope if we have lines, right? Linear equations, and it's not going to work on the C, right? And the other one is we don't always have to go 1 unit increase to get our slopes. And I might, depending on how the activity goes, I might actually do A, B, and C for this first question, and then A, B, and C. As I have it written here, I do all of them for graph A, then everything for graph B, and then C. I don't know, I might mix it up. So depending on how your activity goes, maybe 1 hour I do it this way, and then if it goes well, I continue. If not, maybe I'll switch it up. All right? Okay. The point here, though, is I needed an activity to unpack this conceptual idea. Right? I didn't think just lecture was enough. I want them to construct the ideas. And then how did I do that? I did it all based on my understanding of what the conceptual understanding is. Okay, so very important. Get comprehensive learning goals and unpack them so that you can either develop activities or you can find activities yourself, but you got to know what you're looking for. All right, one more thing before we end this. An easy way to do these graphs, right here, if you have a Mac, you can just go to the Mac grapher, right? So here's the grapher. I do everything in, I don't know, in Mac, so you can see now, once I do my line, 2x plus 1, I get a nice line there, and then I can move everything around. And then all I do is screenshot. So I do Command-Shift-4, and then I can just screenshot anything I want, and then it'll put it on my desktop as an image, and then I can just drag that image over to my, in this case I have a table, right, to organize things. If you didn't want to use the grapher, we had talked about GeoGebra, so open up GeoGebra. Alright, so get GeoGebra. Let's type in our equation. So y equals 2x plus 1. You can see I have my nice line here. I'd actually turn on the grid. Oops, I need to be in here. And then I could do the same thing, Command-Shift-4. And then I can screenshot my line. And again, I'll get an image. And then on my image here, let me minimize some of this stuff. All I'd have to do, so you can see here my screenshots, I just drag them over to my workspace, my document. All right, so find them on your desktop and drag them over. Okay, so let's go back. All right, so now we're up to the top here. I get my first procedural. So here now I'm going to do an example. And you don't have to. I always used to make up my own examples. I didn't use the ones in the book because if students needed help, they always have an extra set of examples in the book that had worked out solutions, so they could go back. Right? So in this case, though, we're just going to copy the example in the book, but keep in mind, I mean, you're the content expert. You don't have to use the ones in the book, and if you don't, then they have extra problems that they can use as a resource. So I have a furniture maker that collects the data in this table, and I want to do these three things. All right, so in this particular case, that's my example. All right, so here's my example. I have a furniture maker. Here's my table, and then I want to do these three things. I made a note before I actually do these. I'm going to ask the class this question. So what do we need to know in order to construct a model? So I'm going to get at the idea that we just unpacked all of this stuff. Okay, so I didn't label this as an activity. It's just a quick kind of, what are we doing before we start activity, right? Question. All right. Okay, and then after C, I'm going to ask the class how the shape of the graph relates to what we would expect for the predicted value. Okay, so now I'm trying to get at this idea of predictions, right? So I'm trying to get them to think about, before we talk about, because I know it's going to come later in this lesson, how the shape affects our predicted value. Right? What I mean by that is, if it's increasing, then I'm expecting my predicted value to be larger than my previous value. And if it's decreasing, I'm expecting my predicted value to be less than my previous value. Okay, so there's my example. All right, now what I want to do, and you'll see I have this right here, this classwork. This is the way I want you to structure things. Let's move this over a little bit so you can see it's different. So what I want you to do is actually construct this kind of framework of, you talk a little bit, you do an example, and then your classwork is their individual work. So on my activities kind of spectrum here, my classwork is going to be both of these. I want you to construct classwork that actually has individuals practice a little bit and work on things that are a little bit different, a little bit harder to try to construct their own understanding. Okay, so that's the goal here. So your classwork, one, should mimic this, and then the other couple, I have three here, right, 1 through 3, and I'll show you why that is. And 3 is not a magic number, you have as many as you need. But I want to do where they do the exact same thing that I did, that I modeled in my notes, right, the lecture. Then I'm going to change things up just a little bit, right? Having said that, I'm just going to take this whole table here because I want the same structure. Okay, so I'll get another document here. Let's call this 1.3 classwork. Okay. I just like to underline it, make it a little bigger. There we go. And then I'll paste. Let's do number 1. You'll see when I paste, the table will be a little weird. All right, so there we go. So now what I want to do is, let's just do a blanket statement, right? How about use the data to answer each question. Okay. And there we go. So now I have final linear model, all that good stuff. And I'll change this actually, since I don't have any context anymore, I'll just change these to X's and Y's. And then you don't have to do any of this, but there you go. So there's my table. So I want them to practice exactly what we did in the lecture. And the lecture is increase by 1 and have an increasing function here. All right, so that's all I want. So I just want to increase by 1, and let's say now I'm going to go by 3s. 21 and 24. So now here they're going to practice exactly what we did. All right, and now the next two, I'm just going to copy this. All right, I need these to go A, B, and C again. So restart numbering, and then restart numbering. All right, and so now notice, and I'll give them some space here, but this is just to illustrate what we're doing. Right, so now what I'm going to do, well, what do I have to work with here? So now how am I going to change it? Well, I don't want to mess with the increase by 1 just yet, right? But notice I have 0 that always starts the table, so I could change that. Notice that these are increasing, I can change to decreasing, and then also notice there are no negative values here. So I can play around with all of those. So to make my kind of different problems, my different classwork, I'm going to mess around with those. So let's start with, let's change this. So we'll go, well, start with decreasing. So instead of increasing, let's do decreasing. So let's do 52, and let's go by, I don't know, 4s. 48, 44, 40, and then 36. So now I have a nice decreasing one. And maybe the next one, instead of starting at the 0, maybe I start at the negatives. All right, so 1, 2. And let's go increasing again, but let's actually start negative as well. So let's do -5, 0, 5, and we'll go by 5s. Right, and these are just arbitrary, written changes, constant changes. All right, so then you can see that's how I actually will practice one, and then I'll change it up to do the other couple. All right, so they're going to mimic what I did. They're going to do something a little differently, so they're going to have to think. So they're going to do something a little different, which is going to change the way they kind of approach the problem maybe. So they have to think about things. They have to construct their own understanding here. So that's my classwork, and you can see in my lesson plan. So that's what I have, classwork 1 through 3. Right, that's why that's here. And actually this practice was just to describe what I did in the classwork, so I don't need that. Okay, so let's go back to so I did my practice, my procedural. So now I'm on the next page. Okay, and look, I have, or you can see I have a nice little conceptual understanding, so I might need an activity. So how can we tell whether a given set of data has a linear model or not? All right, so I need an activity. And then what did I do here? All right, so this is my activity, but before we start that, let's unpack what I mean by that. So let's go to our conceptual learning goal. You can see my third conceptual goal was the shape and the prediction, which I've actually already kind of hinted at, or I've taken care of when we did our second conceptual activity. Right, so that was my follow-up question to see how the prediction changed by the shape of the graph. Right. And if I wanted to, I could actually, in my classwork, I could add a conceptual question here. Right? So there's no reason why you can't. And you'll see when I show you my actual classwork that I do, I put in conceptual questions. Right? So we could have a conceptual question here, and we could ask just that idea. Right? So if I went to my learning goals, right? How does the shape of the graph, right? How does the shape of the graph inform the prediction? Right? So then I'd have a follow-up. So when students finish their actual work here, they would answer this question. Right? So I'm a big fan of the conceptual questions on the practicing. Right? So that's what kind of moves us out of the practice zone into the construct understanding zone. Okay. We don't need that. Let's go. So now our fourth learning goal is just this idea. Right? What's the relationship between the input variable, the input interval, the b-value, and the first difference. So now we kind of want to unpack all of this. So I want to unpack this whole idea, right? Evenly spaced. If the outputs increase by a constant amount, then we get the first differences. So it's this idea that if y is constant, if x has a constant change, then all we have to do is look at the actual change in y to tell if it's going to be linear or not, right? Because that's the idea. So what I'm going to do for this, so before I start, and this is just a personal preference, right? I could have introduced the definition of first differences in the beginning and then done this activity, but I've decided to see if we can't get at what this intuitively means before I do the definition. So in this particular case, I'm having the students actually construct or investigate the definition before I give them the definition. Okay, and this is what I'm going to do. I made a little note to myself. The whole point of this is to show that if the input interval is constant, all we need to look at is the y. Right, so how am I going to do this? I'm going to give each group of 2 the following tables and calculations and graphs. All right, so when I said following, I actually didn't put them in here, but we'll do that in a separate sheet so I can show you what I mean by all that. So I'm going to give them a set of tables, calculations, and graphs. Right? And then I'm going to have them use the handout, right, to answer the following question. When I say handout, it's the tables, calculations, and graphs. All right, what are they going to do? They're going to tell me what the relationship between the change in x is, what the relationship between the change in y is, and what the relationship between the change in y divided by the change in x is. Okay? And what I would do actually is let's connect this to the activity I did before. So when I say the graphs, I'm going to have all of these. Okay, so let's see what that would look like. So let's get a new sheet here, a new worksheet, or Word document. Let's call it 1.3 handout. This is for the first differences, right? So I wanted to unpack first differences, so I'll just put it in the title. Again, it's aesthetics. I like to underline them and make them 14. Okay, so I'm looking for tables, calculations, and then the graph itself. All right, so for the table, I'll do an XY, let's say, let's do, how about 5? One more. So I'll show you what I'm doing here. So let's do centered. This will be my X, this will be my Y. And there's no reason why you couldn't just draw this, but obviously in this video I have to show it like this. So let's unborder these. Cross. Alright, so there's my table. I'll go 0, 1, 2, 3, 4. And then I'll need an actual graph here. Right? I'll need a graph. I'm going to do one more, and I'll show you why that is. Let's get rid of the border. I'm going to insert, actually, I should have inserted a column, or had one more column anyway. Okay, I want to merge all those. So my deal here is, what I want to do is I need a graph. So on my lesson plan, right, I'm going to do this, right? I need tables, calculations, and graphs. And I might as well use the graphs I've already made, right? So I'll have graph A here. So I'll just Command C, I'll copy that, and I'll paste it right here. Right? And that's why I added this last row here. So if this is larger, it won't make my table look weird. I'll just be able to do that with the last row. Right? Okay, so there's my graph. And now I'll need my y values. Right? So it looks like it's 0, I have 5. Okay, and this particular equation was y equals 2x plus 5. Right, so I need 2x plus 5, so 7. Right, so I'm going to increase by 2 every time. So 9, 11, and then 13. Right, and then I'll do my first differences. So what I'll do for those, and depending on how you want to show this, so we'll do 7 and 5. So 7 minus 5 will equal 2. Right, and then here is 9 minus 7. Again, if I wasn't doing this in Word, I'd be able to, connect them with a bracket or a nice little indicator somehow. Right, 11 minus 9, 2, and then 13 minus 11, 2. All right, so now I haven't told them that these are what we call first differences yet. I'm just showing them that they're the differences here. Okay, and then we'd go back to, we've already done our first conceptual activity, and we could go back and relate this to that activity, right? So this is where we got all our 2's. So if we go back to our original lesson plan on this one, remember when we did this activity, we already figured out that the differences were 2. And we've already figured out that if it has a constant increase by 1 in the input values, the x values, then that's going to be the slope. Okay, so we already unpacked some of this. So as I go down, then I would have them answer these questions. Okay, so I'd give them all, or I'd give the groups these sheets. Let's go back to this. And then for each of these, I'd ask them. All right. These questions, right? I'd have these questions ready. Right? So then we're trying to unpack that if this is a constant change, right? Well, I don't care about the x's anymore. All I have to do is know the y's. And we don't have enough yet to do this, right? So this is only the first one we did. So then I'd actually copy this whole thing and I'd do it again, all right, for my second graph, which is the negative slope. And again, we can see constant x's, we're going to have, as long as the y's are constant, then we get a nice linear equation, we're fine. And then we're going to get into the understanding part when we do this exponential one. Okay? All right, so again, all 3 of these would go together. So in my actual handout, I would have 3 of these. So I would copy all this, right? And then I would do it again. But this time I'd put the second graph and I'd change the values. And then lastly, I'd do it one more time. And now here's where I'd have the exponential graph and I'd change the values. Right? But I'd give them these calculations, right? We don't want to waste our time on the calculations. We want to construct the idea of what's going on here. Okay, and then I might even, depending on how the activity goes, I might do a 4th one to where I don't have these as constant. Okay, and then we can see that when x is not constant, it can't be linear either. So I might include a 4th one to follow up, depending if I had time or not. Right? Okay, and then again, the whole purpose of this was because I'm trying to unpack this conceptual goal. Right? I need an activity that gets them at the idea that if the x is constant, the change in x is constant, then as long as the change in y is constant, I know it's linear. Right? I'm trying to get them to figure that out themselves without me just lecturing on it. Okay? And once we do that, then I followed up, and I made myself a little note here on what that all meant. But once we do that, then I followed up with a definition. Okay, so once we've done our activity, right, we finished the activity, then I followed up with the actual vocabulary. All right. Okay, and then once we do the vocabulary, here we'll do an example, and then we're going to practice. All right. So then we'll practice. In this case, I have 4 through 8, and I'll show you why that is. So we're going to go back to our classwork. So I've done my example here. I'm just going to copy this. And you'll notice I used the same example as we did in example 1. So let's go to our classwork. There we go. And now we're on number 4. What do I need? Numbers. Oh, that always happens too. Let's see. And this happens to you where you can't actually change it to the numbers. What I like to do is I'll just hit enter. I'll actually copy all the stuff I just had before. And now you can see I have a nice 4 where I can just get rid of all this stuff. All right, so now I'm back to my 4s. I need to go back to my lesson though, because my copy is off now. So I need to copy this again. And I'll put it right here. Oh, geez. So let's do that. Here's our table. Okay. Right, so determine if the given set of data has a linear model. Right? And again, we're going to copy, we're not going to copy the same numbers, but let's get our x and our y. Right, I don't need the chair, I don't need it in context anymore. Let's, all right, so I just want increases by 1 on the x's, and I'm going to do increasing on the y's themselves. Let's start anywhere. I don't know. Let's do, how about 14, and we'll go by 7s. So 21, 28, 35, and 42. And then I want another one. Start this, continue. Okay, and so now what can we change here? Well, to investigate that, let's ask ourselves what makes things nonlinear. So either the y's aren't constant or the x's aren't constant. Okay, so the first one I just mapped out exactly what we did before. They're just practicing what we did in the lecture. So now this one, I might throw in one more. Let's actually decrease this time. So let's go about 8, and we'll go by, I don't know, 3s. 5, 2, -1, -4. All right, I like this one. Right. Okay, let's do another one. Oops. Continue the numbering. And now in this case, let's throw in some that aren't linear. So now I'll do whether increasing or decreasing. So let's start at 11. Let's go by 4. Let's go by 3. And then let's go by 4. And then 2. Right, so this one will be nonlinear. Right, and then let's do the same thing. All right, and then this one I think what I'll do is let's actually change the x's so they're not going by 1s. Right, so let's go by 3s. Right. 12. So now I have one. Right, it's still going to be linear. So let's make it decreasing again. Let's decrease by 5s. Easy enough to do. Right, so now we need them to check to make sure, or what we're getting at here is if they truly get the idea that it doesn't matter that x changes by a unit increase, it can be a constant increase in any amount. And then I'll do one last one where I'll actually make the y's a constant increase, but I'll change the x's. So maybe we'll go 12, let's go by 2s. 14, 16, 18, 20, and then this time though I'll change from 0, I'll go by 1, how about 3, 5, and then 6. Right, so those are my differences here. Right, so these are the one practice that's just like I did it, and then my variations to kind of get them to unpack the actual idea. So practice to construct understanding. Okay, you can see I made a little note. Here's my classwork. Right, so when I get to this point in my lesson plan, then I'll just say, hey, do classwork 4 through 8. Okay, let's go back to our lesson. So we did all this. We did our practice. And you can see that I actually didn't, in my classwork, my practice, I didn't repeat the find the linear model and then draw a graph, right, to check for accuracy. We could. There's no reason why you can't. I didn't. So, okay, so we're here, we keep following, we don't have any new stuff. No new stuff, and then we finally get to our last one. So here's our procedural. So what I'm going to do is I'm going to need just another example. So I can do this with another example. So in my actual lesson plan, you can see I've labeled it the predictions, and then I'm actually going to start with a question. I want to again kind of lead them into why are we doing something, kind of I don't know, little heads up. So I'd ask why develop linear models, and that'll lead us right into the diver problem. And I'd go right back to my anticipatory set, right, where we had the diver and we wanted to know if she could safely dive at a certain level, right, or certain depth, and we weren't sure. And now that we have the skills, right, to develop a model, to actually plug in expressions or to plug in values and get a result, then we can do it actually far more accurately than we did just that kind of guess and check in the beginning. All right, so then that would be the end of my lesson. If I wanted to, I think I might actually include a couple of these on my classwork. So we went to our classwork. I would actually just include a couple more, right? It's better to overplan than underplan. Right, so I would include, a 9 and a 10 maybe, where they could practice, well, maybe just one of these. Right, I don't know how much you need to practice plugging in values, right? But I would add another one. So I had a 9, and then I'd follow it up with that very last procedural part. Okay, and then that would be my entire lesson. The last thing, though, is homework. Okay, so now what I want you to do is I want you to select homework that is based on the lesson you gave students, right? I don't want any of this kind of just do 1 through 31 odd. When you do homework, when you assign homework, you need to do it for a reason, right? If your reason is to practice, then that's fine. You can do 1 through 21 odd, right? But if you're doing that every single day, then that means you're not putting any thought into your lessons, right? Or you're not putting any thought into what you want students to do for homework, right? Practice all the time doesn't mean anything. You want practice for a purpose, for a point, right? You don't just want random practice. Okay, so then having said that, what do? Well, look at all the stuff that we did in our lesson. We try to unpack some things. We try to unpack an initial value. We try to unpack the constant changes. We did specific classwork problems, right? We changed all that stuff. So we put a lot of time and effort into this lesson. So when we go to our homework, so as I look through my homework, then when I read through these, I want to select homework problems that actually fit the kind of things that I try to get at in my lesson. All right? So as you go through, ask yourself whether or not this problem fits. Right? And what are you looking at? What's given? So how's the problem stated? Is it given a table, a graph? Is there an equation? Right? So what's the problem? What's given? And then what's the solution? So how do students have to actually solve the problem, and what answer do they get? Okay? That's what we're looking for. And as you do this, being an academic part, when you write your lesson plan, I want to see the homework, and I want you to tell me why you chose a problem. So, for instance, so my homework would be 5, 7, 8, 10, 11, 12, 13. I'm going to add another one, and I'll show you, kind of tell you why, and then 19, 20. And then these are the reasons why I chose these problems. I chose number 5 because it got at the definition. Right? I chose 7 because they had increasing y's, 8 decreasing y's. So you look at the problems, you compare my reasons to the problems, you'll understand what's going on. Okay, but when you write a lesson plan for me, this is what I want. When you do the homework, I want the number and I want why you chose that homework problem. Okay, and sometimes they don't actually have enough homework problems, right? Maybe they didn't think about the lesson like you did. So sometimes you have to add homework problems. In this particular case, in this 1.3, they really only focus on a unit increase in x. And I went a little deeper than that. I think students should realize that linear doesn't mean a unit increase in x. It just means a constant change in x. Right? So we went a little bit deeper than this section wanted us to go. And having done that, I need to add a homework problem. So now what's going on here? I want to be clear about when you write a lesson plan, what do I need? Okay? You don't have to actually write out the learning goals. Okay, but you should. Well, when I say that, what you should do is you do need to unpack this stuff. So this is all about unpacking my understanding of the conceptual goals is what helps me write the activities, helps me generate the activities or find activities. Okay, but all these other goals, the actual dark bullets, right, those were all found on our marked up section. Okay, so when you do a lesson plan for me, the bullets, I don't need, you don't have to rewrite them, right? I'll just need to see your marked up lesson or your marked up section, right? And I'll get the gist. Okay, but I do want to see your understanding of the conceptual parts. Okay, so I do want this. Right, so give me the conceptual goal and then give me what your understanding of that goal is. Okay, all right, so that's the learning goals. Mark up your section and then unpack the conceptual for me. Okay, do any prior knowledge that you need. Okay, and the prior knowledge will come from, you notice I only have 2 here. The prior knowledge comes from when I start doing the actual examples, then that's when I'll do my prior knowledge. You don't have to front load this, right? So more often than not, I just leave these as a bullet, blank bullet. And then as I work through my examples and I create my classwork, then I'll come back with what do they really have to know, right? And prior knowledge could be, there could be 30 things here, right? But you can't have that many. So I'd never have, 4 is kind of an arbitrary number, but I try to limit it to 4 or fewer. So if you do have a list of students absolutely have to know these 10 things, then put it in a hierarchy and only do the top 4. What do students actually absolutely have to know to engage in this lesson? And don't go with this whole assuming that they do know things. You can engage prior knowledge in the first 5 minutes. It's well worth it to go over something everybody knows to make sure we're on the same page, then skip it and have students that are lost. All right. Okay, so learning goals, I want to know some prior knowledge. I want some type of anticipatory set, right? This could either be a hook where you just engage students to want to follow the lesson, or it could be a review of prior knowledge. right? This is where I would do the review of prior knowledge. Okay, then I need your lesson. So complete with all your definitions, complete with your examples, and then I also do want classwork. Okay, so through all of this, you should have sections of you lecture a little bit, and then you do some examples, and then they practice. So it's going to be that continuous cycle. You do a little bit, they do a little bit. You do a little bit, they do a little bit. And I want the classwork. All right, so you'll develop classwork. All right, so when you hand in your lesson plan, I should see up to this part, I should see learning goals in your section all marked up. I should see your prior knowledge, right? Well, your conceptual unpacked. Prior knowledge, I should see some type of warm up or anticipatory set. A lesson where you do a little bit and then followed up with classwork, and I should see the classwork. And then the very last thing is the homework. I want to know what homework you assigned, and I want to know why. All right, so those 4 things should follow every lesson plan you give to me. Okay, now the last thing, let me actually show you, since I've actually delivered this lesson, and the one I created for this class is a little different than the one I actually do. Let me show you what I would do. Okay, so first, this is my lesson plan, right? So here's the prior knowledge. Here actually I have 5 things, right? I'm going to do differences just to make sure they understand how to, subtract. Exponents, so I'm going to talk about linear equations, so I want to make sure they understand that x with nothing is x to the 1, what a y-intercept is, and then how to check an ordered pair, plug in 2 and see if it's right, because we're going to check accuracy. And then I also need them to graph a line. All right? And now, having talked about our lesson before, I might change some of these. So I think the substitution is good. I don't know, it depends on how things are going. Okay, you can see my first part, I'm actually making the connection between data, graphs, even though that graph didn't come out well, there's a grid behind there, and equations, so I thought that was important, right, to really get them to understand how that's all connected. Then I have some class questions here. Then I go right into a definition, and then I'll do our interpretation. So these are the arrows I was talking about. So this is my note when I actually write this on the board. Then I'm going to make these notes there. And then I have an example. And then I have 2 classworks. So when I look at my classworks, right, here's 1, and then here's 2. And I do my conceptual questions with an asterisk, not a CQ. Right, so let's make this a little smaller. So you can see they're going to finish this one, or they're going to do this problem, and then they're going to answer this question. And then they're going to do this problem, and then they're going to answer this conceptual question. Right, so that's all in my lesson plan. So I do my lecture a little bit, then I do classwork, 1 and 2. All right, and then here's a little note to myself. This was actually just what I'm going to tell the class. And then I have kind of a lead-in question. So how can we determine if something's linear? So I'd ask that to the class, and we'd see. All right, and then we go into, this is just a nice definition, right? So I actually didn't have this, the activity I had before where we actually lead them into first differences. Okay, and keep in mind, this actual lesson was taught to college students. I like the lesson that we developed better than this one because it gets more in depth and it really hits at the understanding part. Okay, in secondary, realize you're going to have 5 days a week, 50 minutes, 5 days a week with students for 18 weeks, right? In higher ed, you're going to have 3 days a week, 50 minutes for only 15 weeks, right? One of which is a reading week and one's a finals week. All right, so here's the idea is I get pretty much half the time to do what I need to do. So although I loved what we did in the other lesson as a college class, you can't do it, right? It's just not enough time. All right, so having said that, then you can see here I have my other example, and then I do classwork 3, right? And then I'll do this example, and then I'll do 4 and 5, and then I'll do this one. Okay, and then you can see my classwork, all the same stuff. So here are my variations. I'm going to practice a little bit, then I have them do some other stuff, right? Then I do just like we talked about, where one's what I did on the board, and then I do a couple harder ones or different ones. Okay, and I always kind of follow them up with these conceptual, not all the time, but most of the time. All right, so that'd be my classwork. Make it smaller. I always give them solutions. So you'll notice I actually have answers to the conceptual as well. I put this on a document camera, and I'd turn a sheet of paper over and hide all this right here. So I'd only show them these parts first. And then once I asked the class, I'd elicit some responses to the conceptual questions, and then I'd go over the answers. Right? So then I show them the answers. I give them a little bit. I let them try a little bit, and then as I'm walking around, I'll eventually go to the document camera and move it down so they can see the answers. But I wouldn't give them the answers right out of the chute, right at the beginning. I let them try a little bit. Then as I walk around, I'll move the paper that hides the answers down. Okay, so that's my classwork with my solutions. Okay. And then homework. Here in my homework, so I always give them the solutions of the homework. So here's what I would show them for the homework solutions. I got fancy, or I get fancy, I guess. I put the things in red that are actually answering the problem. I don't know if that's really necessary. But everything in black was given, and then red's the stuff that I added, the actual answers. I make them do conceptual questions, I make them do key concepts for every homework. So I actually put what I think are key concepts. Now, they don't have to have the same key concepts I do. It's just the idea that it's a kind of a model of what could be a key concept, right? And a key concept is something that you learn while you do the problem, right? So if you do a homework problem, or if you do a whole homework assignment and you don't learn anything, then it was a waste of your time, right? So if you do learn stuff, I want to know what it is. So here are possible things I could have learned just by doing problem 10. Here's something I could have learned by doing problem 8. All right, so I include all that stuff. You can see at the end, we had talked about frameworks. Here's my framework, or my kind of solutions to the framework that I have them do for homework if they want to follow it, right? Get a core concept of the section and then break down the actual section, right? What was the question, what was given, what was the solution, right? What was the question, what was given, what was the solution? Then I have kind of a map of my section, right? Okay, well that would be my 1.3 complete lesson with the lesson plan, the homework, the classwork, all that good stuff.